Yesterday we had done the loading calculations, as well as after loading calculations we had done shear force and bending moment calculations, and after shear force and bending moment calculations we had calculated the reinforcement details. We had calculated the main reinforcement, as well as we are done with the secondary reinforcement. For main reinforcement, we have taken the 10 mm 5 bars in order to calculate the spacing. And for secondary reinforcement, we have taken the 8 mm 5 bars. And after that, after calculating the main reinforcement and the secondary reinforcement, we had checked the design for the shear. Now the next step is to check for the deflection. Yes, I hope everyone understood up till step number 8. And everybody had completed up till step number 8. So we'll proceed with the next step, that is step number 9. Yes, Mujahid, you want to ask anything? You are having any doubts? Okay. So I need to check for the deflection. Okay. So we need to check now for the deflection whether our design is safe for the deflection or not. So for that, we are having the formula, that is Fs will be equals to 0.58 Fy into AST required upon AST provided. So for that you need to refer page number 38 of your IS code. On that you will get this formula for calculating Fs, that is 0.58 into Fy into AST required upon AST provided. So see the IS code, page number 38. Of the same IS code, that is IS 456-2000. See here. Here you are having the formula to calculate Fs. That is 0.58 into Fy into area of cross section of the, that is AST required upon AST provided. So from this page number 38 you can refer this formula to check for the deflection. So here there is figure, so correct, do the here correction, that is the page number 38. So after substituting all the values, already you had calculated the AST required and the AST provided. So AST required आपको मिला था 775.38 and AST provided you had got 785.4. तो उसपे से आपको FS की वैल्यू मिलती है 237.63 megapascal, and already you had calculated the percentage minimum and Fs. So from that, modification factor is 1.4. First of all, complete up till here, calculate the value for the Fs. Then we shall proceed further. Fs is nothing but the tensile stress in the reinforcement. After calculation of Fs, let me know so that we can proceed further. Those who were not there in the yesterday's lecture, leave 2 to 3 pages and then start with the step number 9. and be regular for at least designing subject. Otherwise, it will be difficult for you to understand. Fs is the tensile stress in the reinforcement. So tensile in the stress in the reinforcement comes up to be 237.63 megapascal. Yes, calculate Fs, and after completing, let me know. Yes, done. Completed. Should I proceed further?
Yes, yes, ma'am.
So for percentage 0.39% and Fs manufacture modification factor is 1.4. So how the modification factor get? See, Fs आपको कितना मिला है? 237.63. So somewhere here there will be the value 240 के नीचे, and the percentage tensile reinforcement, that is minimum percentage, is 0.39. So for it is something here. So यहाँ पे somewhere there will be the value for the modification factor. So modification factor we will take it as 1.4. That is 237 Fs, and percentage minimum is 0.39. So from this graph, that is on the page number 38 of your IS code, you will take the value of modification factor. So यहाँ पे somewhere you will get the modification factor, and that value will be 1.4. So modification factor will be 1.4. And as I've told you, we are calculating for the simply supported. We are considering the beam as a simply supported. So for that, D will be equals to L effective upon 20 MFT. This is again on the page number 37 of your IS code, IS 456 2000. See here, for simply supported, the value for it is 20. Okay. So that's why we are taken L effective upon 20 into MFT. MFT is nothing but the modification factor. So L effective is here, do this correction. Here there is 4700, no, not 9700. So do this correction. Here there is 4700 upon 20 into modification factor, that is 1.4. The value comes up to be 167.85. It is less than the D that you have calculated earlier in the previous step. So your design is safe for the deflection. So do up till here, then we will proceed further. And if any doubts, you can ask. After completing, let me know.
मैम उसने यूनिट गलत लिखा है, एमपी ने एमएम आएगा ना 167.85।
Yes, yes, there should be mm. Do this correction. There should be mm. And here there is 4700. L effective की वैल्यू आपकी 4700 है. Is completed up till here. Completed step number 8. Everyone had got this answer. That is 167.85. Okay. So now proceeding for the next step. That is the check for the development length. So only I am here showing you how to calculate the development length. But in case of the staircase, all the tension reinforcement will goes into the support only. So there is no need to check for the development length. But just for your knowledge, I am telling you how to calculate the development length if suppose it is necessary. But in all the staircase sum, no need to check for the development length. No need to do the check for the development length. So see here in these particular cross sections, these are the all bent up bars are shown over here. And here there is the spacing provided to you, that is 400 millimeter center to center. And again here this spacing is your 200 millimeter center to center. And the formula to calculate development length is 1.3 m1 by v plus L0 should be greater than LD. Where M1 is the movement capacity due to tension reinforcement and the support. M1 is the movement capacity of the movement due to tension reinforcement as well as support. Again, the value of M1 when the bars are bent up. जब भी आपके bars bent up bars रहेंगे, at that time you have to consider the value of M1 as M by 2. And if it is not bent up bars, then you have to consider the value of M1 as M. And V is nothing but the factor shear force. L0 is the length of anchorage beyond the center of the support. Here, this one. This is your L0. Then BS by 2 is nothing but the 20 millimeter clear cover plus the hook length for 90-degree bend. The formula is BS by 2 minus 20 plus 8 into diameter of the bar. And LD is your development length. Again, formula is 0.87 F1 into 5 upon 4 tau BD. Phi is here diameter and tau BD is your bond stress in megapascal. You have to increase the value of bond stress by 60% if the grade of the steel is Fe415. Again, this is on the page number 43 of the IS code. Just for the knowledge, note these steps, because as this is our first problem for the staircase, just for your information, note down this, check for the development length. But in paper, no need to do the check for the development length. But in other designing sums, that is for the design of these retaining wall and the water tank, you will need this check. You have to check for the development length also. Only in case of the staircase, you don't have to do the check for the development length. Note down these, and if any doubts, you can ask. After completing, let me know.
मैं ऊपर करूँ ना, सॉरी नीचे करूँ ना.
Yes. Yes, completed up till here. Should I scroll it down? Okay.